So welcome everybody in the second week of the course on energy economics and policy. In this week and in the following week, we are going to discuss various topics that will make us understand how to measure energy demand or how to understand various nuances of energy demand. This is the second module, as I promised we'll discuss this week. And when we talk about energy demand, let me begin with this understanding. Energy demand is a little bit different from what you understand for the demand for food or demand for clothing or demand for any other thing. Why is it so? Because it's a little bit complex. See, if you have electricity, probably you can't use only electricity if you don't have the equipment which can convert electricity to the energy services. So if you actually what you need is the lighting service, what you need is the space cooling service, what you need is the service for cooking. So you need some equipment which can convert the energy to some usable form. So therefore, as a consumer, your decision has different layers. What are these different layers? The first question that you have to ask yourself, what is the kind of appliance that you want to use? So this is the decision related to the appliance or the technology. The second thing is that once you decide on the appliance or the technology, now you have to think about the type of fuel that you want to consume. The third stage comes in the form you want to take a decision related to the level of your consumption. So how much energy do you want to consume? If you look at the literature, in some of the literature they say that this comes sequentially. So first you decide about the technology, second you decide about the type of fuel, and finally you go on and decide about the amount of energy or the level of energy that you are going to use. But you will see that in everyday life, actually this kind of sequence may not be followed. So you may first decide what kind of energy that you want to use, and therefore you make the choice of the equipment. This is pretty much possible. So let me just give you an example. So what is the decision related to the appliance or technology? This is kind of a question that you ask yourself. Should I buy a car? So should I buy the technology? Should I buy the equipment? This is the first question that you are asking. The moment you decide to buy a car, the next question that bugs you, what kind of car do I buy? Do I buy a car which can be driven by petrol or by diesel, or should I spend a little bit more to buy the electric vehicle? Now, why is it important to take this kind of decision? Because if you see, you look at there are two types of costs associated with your decision. So if you look at this kind of example, you have to spend less amount of money if you are going to buy a petrol car or a diesel car, but your running cost is going to be high. However, if you are going to buy, the electricity driven car, then your initial cost is going to be high, whereas your running cost is going to be low. And by doing this, you are also making a decision about the type of fuel that you want to use. Whether you want to use electricity for your mobility service or you want to use petrol for your mobility service. Now, once you decide on that, and suppose, for example, we assume that you have decided to buy the electric vehicle, the next question that you ask yourself, how many kilometers should I drive per day? So these are all related decisions that you have to take when you are thinking about, using a particular form of energy. Now, as I said that it's not necessary that these decisions has to be taken in a sequence. It can be the other way around. For example, you already have electricity at your home, right? So you have already decided about the type of fuel that you are going to use. However, now you are deciding about the technology that you want to use. Whether you want to use the tube light, whether you want to use the LED, whether you want to use the incandescent, it all depends on you. So you should not be highly bothered about the sequence, but there are three stages of decision that you have to make, whatever sequence it may come. So this is the fundamental thing that you have to remember whenever you are thinking about the demand for energy. So again, to come back to what is the difference between the energy demand and the energy service demand. See, the amount of electricity that you need, that is your demand for energy. But the amount of light that you need is the demand for your energy service. So lighting is basically not the energy, but lighting is the energy service that you need. When you are consuming energy, your energy consumption or your electricity consumption is being measured in terms of kilowatt hour. Whereas when you are measuring the energy service that you are deriving out of the electricity along with the equipment, then you measure the lumen of light, that is the brightness of light that you are consuming. So there are two aspects of energy demand. One is energy and the other is energy service. As we have said that we need to discuss some of the basic concepts in economics and policy making as we go on. So in this lecture we are going to devote some time to understand what is the economic foundation to understand the demand of both consumer as well as producer. Let us first have a look at the consumer demand. In a nutshell, if you consider yourself as a consumer, when you take a decision to consume something, what are the factors that you actually take care of, that you take into account? So you go to a shop, you want to buy two different things. Now how much you buy one particular thing and how much you buy the other particular thing, it depends on how much you like one as compared to the other, or how much do you need one as compared to the other. And the second determining factor is the money that you are carrying. So there are two driving forces if you think about the consumer's demand. One is the preference pattern and the second is the budget. So the interaction between these two concepts actually generate some kind of an equilibrium for the consumer. So what does the consumer do? The consumer essentially maximizes the utility that she derives out of the consumption of different goods and services subject to a budget constraint. So subject to the money that you have available for spending. Once you do that, what does the equilibrium tell you? The equilibrium in the context of energy tells you what is going to be your energy demand, or you can convert it to energy service demand. So this is, in a nutshell, this is the framework within which we try to analyze and understand the consumer's demand of energy. Coming to the producer's demand, the framework is pretty much same analytically, but it has a different implication. So what does the producer do? See, the producer usually is operating with some kind of a production unit. So once a production unit is already set up, then the capacity is decided. So usually what the producer has a target to produce a particular amount of goods or services. So the production target is sort of fixed for a particular producer. So what does the producer do? The producer will try to minimize the cost subject to a production constraint. So I want to produce 2 tons of steel. What is the minimum cost that I need to incur in order to produce that amount of steel? When this kind of exercise is being done, so you see what the producer is doing. The producer is deciding what is the minimum cost so that it can meet a particular production target. So cost of what? It's the cost of input. The input price and the quantity of input that the producer is consuming, that determines the cost, and that in a way also determines the amount of production that you can undertake. So when we are talking about cost, this is basically the cost of input, and there comes the role of energy, because in the production process energy is used as an input. So when we discuss the energy demand in the context of producer behavior, we actually talk about the derived demand. So this is the input demand for energy, or this is called the derived demand for energy. In next few slides, we are going to focus on consumer's demand, and we will see how analytically we come to the equilibrium for a consumer and how does the demand curve for a consumer look like. We begin the discussion with the concept of indifference curve. So what is the indifference curve? This is the fundamental representation of consumers' preferences. So what is happening on an indifference curve? Here you see, let us spend a little bit of time here. Here you see this is a 2 commodity framework. On the x-axis we have energy. So this is the amount of energy the consumer consumes or wants to consume. And on the y-axis we have some other goods or services. So I have kept recreational activities. For example, you can take, sort of how many pizzas do you want to eat versus how many liters of petrol do you want to consume if you have a particular amount of water. So, if you have a particular amount of money in your pocket. So, you see these convex downward falling curves, they represent your preference pattern. So, what is happening here? These are called indifference curves. and which captures the preference of a consumer here in the context of energy and recreational activities. So what is the speciality of this curve? The speciality of this curve is that on this particular curve, your utility is going to remain the same. So the satisfaction that you are deriving by consuming different combination of Q1 and Q2 are going to be same on this particular curve. So that is the feature of this curve. Any point on U1 will also yield the same level of satisfaction. Any point on U2 will also yield the same level of satisfaction. Therefore, the preference of a consumer is represented by a function U, which is a function of Q1 and Q2, and as we have already discussed, utility is constant on a particular indifference curve. Let us look at different other features of the indifference curve. So the indifference curves are generally, mark this word generally, there can be exception, but we are talking about the basic kind of framework. So we will assume that the indifference curves are continuous, downward falling and convex to the origin. What does the downward falling mean? What implication does it have? It implies, suppose you are on point A on the indifference curve U0. So this is yielding the level of utility or the level of satisfaction which is equivalent to U0. Now suppose you want to increase your consumption of energy. So you want to move rightward, right? The moment you increase your consumption of energy, keeping your consumption of recreational activities unchanged, basically what is happening, your total consumption goes up. And the moment you increase the consumption of any one of the commodities or the services that are represented in the X or Y axis, your utility level goes up. So in order to keep your utility level constant, what you have to do, as you increase your consumption of energy, you have to reduce the consumption of recreational activities. Therefore, if you want to be on the same level of utility as represented by A, you have to move to a point which is B, which will be situated at the southeastern part of A. Therefore, you have a downward falling indifference curve. Similarly, you could have discussed that if you want to move from A by reducing your energy consumption, then you would have had to increase your consumption of recreational activities. So, on the same indifference curve, since the level of utility is same, it has to be downward falling because increase in consumption of one commodity or service has to be compensated by the decrease in the consumption of the other commodity or service. So that is why we have the indifference curves which are downward falling. Coming to the next crucial observation, we have drawn the indifference curves here as convex to the origin. Again, the disclaimer is that there can be other types of indifference curves. However, this is the most general framework within which the consumer equilibrium can be discussed. So what does the convexity to the origin implies? See, you have a convex curve, downward falling convex curve where the slope is increasing as you increase the consumption of Q1. Or if you think about the absolute slope, the absolute slope is actually declining as you go on consuming more of Q1. So the absolute slope declines. Now what is the meaning of the absolute slope? This has a specific meaning as we are discussing the behavior of the consumer. The absolute slope has a name. It's called the marginal rate of substitution. And it tells you the amount of Q2. So marginal rate of substitution tells you the amount of Q2, that is the recreational activities that you are willing to sacrifice in order to increase your energy consumption. So as you increase your energy consumption, how much recreational activities are you willing to sacrifice? So this is the marginal rate of substitution between the two commodities which is captured by the absolute slope of an indifference curve. Now when I am saying that if you increase the consumption of energy, this absolute slope is declining. What is actually going on in the consumer's mind? Basically, when you keep on increasing the use of energy, energy doesn't remain that useful to you. You have abundance of energy at your disposal. However, you have very limited amount of recreational activities with you. So the recreational activities become more valuable And at this point, probably the energy is not so valuable for you because you already have the amount of energy that is essential for your consumption. So beyond the point, if you want to increase the level of energy that you are consuming, you are really not ready to sacrifice any amount of recreational activities. And therefore, the marginal rate of substitution declines as you increase the consumption of actually any of the commodities. Here we are talking about Q1, but this is true for the other commodity as well. So that is why we have the indifference curves which are convex to the origin and as well as downward falling. Next, we are going to discuss about the location of the indifference curve and the level of utility. If you move on from U0 to U1 to U2, that is if you move away from the origin, the indifference curve actually represents a higher level of utility. Why so? Again, come back to point A where you are consuming a particular amount of Q1 and a particular amount of Q2. Now we have already mentioned that if you increase the consumption of if any of the commodities, that is going to increase your utility. So the consumers are actually never satisfied. The more the commodity or services that you have to consume, more satisfied you are. So if you want to move from point A along this particular ray, it shows that your consumption of both the commodities are increasing. So from A, if you move on to a point like A prime, there is an increase in your consumption of energy. There is an increase in your consumption of recreational activities. So both the commodities are increasing. Since both the commodities are increasing, then the satisfaction level, that is the utility that you are deriving at point A prime, is higher than the utility that you are deriving at point A. We also know that on U0, all the points represent the same level of utility. And similarly, all the points on U1 represent the similar level of utility as of A prime. So if we can say that the utility derived at A prime is greater than the utility derived at A, then in general we can say that the utility derived on any point of U1 will be greater than the utility derived at any point on U2. And therefore, as you move out of the origin, you are actually going from a lower indifference curve, which is giving you lower utility, to a higher indifference curve. And therefore, as a consumer, your objective will always be to move on the outer space. That is always to move on from a lower level of utility, lower level of indifference curve to a particular higher level of indifference curve. So that is what you want. That is what you do as a consumer. That is what your optimization technique is. Let us have a little closer look at how exactly things go on. Next we come to the budget line. So what is the budget line? So you have some amount of money. You have 100 rupees to spend and you have two things to buy. One is the recreational activities, that is, for example, you want to buy pizza and you want to buy some petrol. How do you decide to spend or to divide this M amount of money between these two commodities? For this, we actually need the information on the price of these two commodities. So you see that we have actually assumed that the price of energy, that is price of Q1, is P1 and the price of recreational activities, that is Q2, is P2. Once we have these three information, then we can draw a budget line Rn which looks like this. Now what are the features of this budget line? See, this is simply a downward falling straight line in some Q1, Q2 plane. If that is the case, then what is the slope of this budget line? The slope of this budget line is given by minus P1 by P2. So that is your dq to dq1. And the equation of this budget line is given by P1 Q1 plus P2 Q2 is equal to M. So P1 Q1 is nothing but the total expenditure on Q1 and P2 Q2 is the total expenditure on Q2. So your entire money income is being divided between the expenditure on recreational activities and expenditure on energy. So there is no balance which is left. So the basic assumption is that you are spending all the money that you have. And this is the slope of this budget line. Now let us have a quick look at what is happening on the points that we have noted as N or as R. See, at N, if you come to this point, Energy consumption is here, but what is the consumption of recreational activities? That is 0. So at point N, you are spending all your money to only buy energy and no recreational activities. So at N, what is happening? Q1 is equal to M by P1. So all your money is being spent to buy the energy and Q2 is equal to 0. Similarly, at the point R, you are not buying any energy at all, right? So at point R, you have Q1 equal to 0. So your energy demand is equal to 0, or the amount of energy that you can buy is 0. Or Q2 is M by P2. So your entire money income is being spent to purchase the second commodity, that is the recreational activity. So these are the two foundational things that are going to interact to decide the consumer's equilibrium. One is the preference, which is captured by the indifference curve, and the other is the ability to purchase, which is determined by the money income and the price, that is through the budget line. So one thing to note is that, see, the consumer always has to operate within this triangle RON. The consumer cannot go beyond this line. So the consumer cannot operate somewhere here because this is beyond the consumer's budget space. Now let us have a quick look what the consumer actually does. So the objective of the consumer, as we have already discussed, is to achieve the highest indifference curve that can be achieved given a particular budget line. So the problem optimization, it's a constraint optimization problem where you try to maximize U, which is a function of Q1 and Q2, and what is the constraint? The constraint is given in the form of the budget line, that is P1 Q1 plus P2 Q2 is equal to M. So this is the budget line. Now if this budget line is given, then let us superimpose the preference pattern on this, and you can see what is going on here. See, if we think about U0, it's not quite rational for the consumer to choose any point on U0. Although at this particular point where the cursor is, you see at this point the consumer is actually spending all her money because this point is on budget line. Or you can think about this point where the consumer is spending all her money. However, this is not really rational for the consumer to stay on U0. Because by spending the same amount of money, the consumer can reach a higher level of utility. And as we have already discussed, that the target of the consumer is always achieve the indifference curve, which is in the outer space. So you want to achieve the highest indifference curve. What happens in case of U2? At U2, if you see, if this is the point of equilibrium, this is probably the highest level of utility that the consumer can attain given the particular amount of budget. So here she is not only spending all her money, but this is the highest attainable IC. Because if you go beyond this, for example, the indifference curve which is captured by utility level U2, this is beyond the consumer's reach. Because to reach any of the point on this utility curve, you actually have to spend money more than what you have. So this is not within the feasible set of the consumer. So we can see that this point E becomes the consumer's equilibrium. And if point E is the consumer's equilibrium, this is the amount of Q1 and Q2 that will be consumed by this particular consumer at point E. Now how to solve the problem? This problem, if you are in a multi-commodity framework, this problem can be solved with the use of the Lagrange, the usual way the constraint optimization problems are solved. But here, because we are in a simpler framework with only two commodity, one observation can help us to solve this even more quickly. What is the observation? See, E is the equilibrium. What is the speciality of E? At E, the slope of this particular indifference curve is equal to the slope of the budget line. So this is the peculiarity of this point E. If that is the case, we know what is the slope of the indifference curve. This is the marginal rate of substitution or the negative of the marginal rate of substitution. Because as you see, if you say that the slope of IC is equal to slope of the budget line, it also says that the absolute slope of IC is equal to the absolute slope of the budget line. And the absolute slope of IC is the marginal rate of substitution, and the absolute slope of the budget line is the relative price, that is P1 by P2. So at equilibrium, we know that the marginal rate of substitution is equal to P1 by P2. If you are interested to understand the nuances and the interpretations of this, you can refer to any of the undergraduate economics textbook to understand this. But we are not going into further details with regard to this, but we'll just see how the the equilibrium is fixed or the equilibrium is decided. So this is the equilibrium that is obtained by the consumer at point E, and this is the most important thing to remember. At this point, MRS, that is marginal rate of substitution, is equal to price ratio. Now see, we have determined the equilibrium for the consumer in the Q1 Q2 plane, but we haven't yet talked about the demand curve for the consumer, because when we talk about the demand curve, we actually have to talk about the correspondence between the price and the quantity. So now from the two commodity framework, we have to move on to the one commodity and the price of that one commodity. So we have chosen energy for that. So what we are doing, we have to pay a little bit of attention here in the construction. See, this is our known panel so far. This is Q1, Q2, right? Here we are plotting Q1 and Q2. But below that, what we are doing, we are keeping this Q1 axis unchanged. So whatever we plot on this axis, we can just take the image here. So it captures the same things, Q1. However, in the lower panel, instead of plotting Q2 here, we are plotting P1. So if we can derive some kind of a function on this plane, that is the P1 Q1 plane, that will tell us about the correspondence between the price and the quantity. Now the question is, how do we derive this price quantity correspondence based on what we have learned about the consumer's equilibrium? So it goes on like this. See, one thing you have to notice, we are not talking about P2 here. So we can't consider any change in P2. So we will keep the price of the recreational activities, that is P2, that is the price of Q2, unchanged. So in our whole analysis, now on, the P2 is not going to change. What is going to change is only P1, because we are trying to understand the correspondence between P1 and Q1. So the first thing that we have to do, we have to fix P2, and let us assume at the beginning the price of the first commodity is P1 naught. So this is the first price that we begin with. Now if we already know that the price of the first commodity is P1 naught and the price of the second commodity is P2, then we know that we have a budget line whose slope is minus P1 naught by P2. So this is the budget line that we have. Given this budget line, if I want to optimize, and if this is my preference ordering, this is these utility, these indifference curves capture my preference, then obviously my equilibrium is at the point E naught. What is happening at E naught? I am not interested how much Q2 I am consuming, but now I am only interested in how much Q1 I am consuming. And I am consuming Q1 up to this point, which I take up to here, and I consider and I give the name Q1 naught. Now see what this point A naught is saying. This point A naught, is telling you if the price of energy is P1 naught, then you will be consuming energy whose quantity is equal to Q1 naught. So definitely the point A naught is giving you a correspondence between the price and quantity of energy demand. So definitely A naught is going to be 1 point on the demand curve. This is the reference point on the demand curve. Let us see, now see, in order to get any function, I need at least one more point. So that is what I am trying to do now. Let us now change the price of P1 from P1 naught to P11. So now the price of energy falls. For some reason, this may not be very logical, but for some reason the price of energy falls. Now if the price of energy falls, what happens? There will be a change in the slope of the budget line. So now the slope of the budget line becomes minus P11 divided by P2. Now since P11 is less than P1 naught, you can see that the absolute slope of the budget line has fallen. So this is the new budget line that you have. See, this point doesn't change. It's kind of a rotation. This point doesn't change. Why does this point not change? Because if you spend all your money only to buy recreational activities, then the amount of recreational activities that you can purchase, even with the changed price of energy, is going to remain the same. So this point is not going to change. However, now if you spend all your money to buy only energy, you can buy a lot more amount of energy. So the budget line shifts upward, or you can say the budget line actually rotates upward. Not only that, as the price changes from P1 to P11 and the budget line shifts, now you can achieve a higher indifference curve. You don't have to stick to U1, you can move up to U2 and E1 becomes your new equilibrium. So if E1 becomes your new equilibrium, then eventually the demand for energy increases. So you see, as the price of energy falls from P1 naught to P11, your demand for energy increases from Q1 naught to Q11 and you shift from the point A naught to point A1. Now both these points, they are telling us about the correspondence between the price and the demand for energy. Now if I join these two lines, what I get is actually the demand curve for energy, which is telling me the relationship between price and quantity. And what is the slope of this demand curve? The absolute slope of this demand curve. So when I write slope, it is basically the absolute slope of the demand curve is dP1 dQ1. So what does the slope tell us? The demand curve, the slope of the demand curve, what does it tell us? It actually tells us if there is change in the price, what is going to be the response in terms of energy. You can imagine a flatter demand curve here. If the demand curve is flatter, then what is the response? The response is going to be higher because the same change in price will actually lead to a much bigger change in your demand. If your demand curve is steeper, then you can expect limited change. So a steeper demand curve actually represents less responsiveness, whereas a flatter demand curve actually represents more responsiveness. So in the coming lectures, we are going to link this idea of responsiveness with something called the elasticity of demand. So we will discuss the price elasticity of demand, where we will explore if there is 1% change in price, what is the percentage change in demand. Not only you can explore the impact of change in own price, that is, not only you can explore the kind of what is the impact on energy if the energy price changes, but you can also explore the effects of cross prices through cross price elasticity. There what you do, you try to understand if there is a change in the price of Q2, what is going to be the impact of Q1. So that is the cross price elasticity, which we will be discussing in the future slides. So that is more or less the end of consumer's demand. That is how the consumer demand curve is derived, and we will quickly spend some time to understand the producer demand. This is pretty much the same. If you understand the basics of the consumer demand, you can also understand the nuances of the producer demand, but producer demand for inputs. Before I go into the discussion, let me just tell one thing. So what are the different inputs that the producer usually requires in order to carry out the production? So in the general economic literature, you will find that capital is one of the major inputs. Capital may include any kind of machinery, the building that you have, the process that you are using and all. So this is the investment goes to capital formation. This is one input. The second input is labor. So you need labor for the production. The third input considered is energy. The fourth input considered is material, and the fifth input often which is considered is the service. So these are the major 4-5 inputs that is usually considered when we analyze the producer's demand. And each of the input may have its own demand curve, because the way we have the consumers go to a product market, the farms have to buy these inputs from the input market. So there are input prices as well. So the price of labor is the wage. The price of capital, we consider this is the rate of interest. So there are several prices for several inputs. Similarly, if you think about energy input, energy also needs to be bought from a particular market, and that has a particular price. So the behavior of the producer, that is how much energy the producer wants to buy, will actually depend on how much the producer wants to produce and what is the cost of energy in the market. So if you keep this thing in mind, it's pretty much the similar kind of framework that we have used for consumer demand. So here we come across two concepts. One is called an iso cost line and the other is called an iso quant line. So we start with the ISO cost line, and you may recall that what was the objective of the producer? The objective of the producer is to minimize the cost subject to a production constant. So coming back to the ISO cost line. What is the ISO cost line? See, I have chosen two inputs here because if you are doing a two-dimensional diagram, then you can't go beyond two inputs. But this can be readily extended to any multiple number of inputs. That is possible. Only the diagram becomes a bit clumsy, so that is why we restrict ourselves to two commodity framework or two input framework. So what is happening here? This is the space for the producer. So the producer has to buy some capital and some energy with the money that it has. So, and it's not exactly with the money that it has, but it has to decide how much capital and how much energy it has to buy, and so what is going to be the cost. Now, what is this line? This is an ISO cost line. What is happening on this ISO cost line? This is the analogy of the budget line. So here the equation of the ISO cost line is given as PE multiplied by E plus PK multiplied by K is equal to C. So PE is the energy price. PK is the price of capital, which is often referred to as rent as well. So if you, and PE multiplied by E, this is the expenditure on energy, and PK multiplied by K, this is the expenditure on capital. If you add them up in this two input framework, this is the total cost that the producer has to incur. Now, if you increase the quantity of energy and capital purchased, then the cost that you incur is also going to increase. So, as you move outward, basically you are moving from a low ISO cost line to a high ISO cost line. And similar to what consumer was trying to do, here the producer will actually try to choose an ISO cost line which is closer to the origin. So, it actually tries to minimize the cost of production. And also similar to the the budget line, on any point on this particular ISO cost line, the cost that is incurred is same. So what is basically happening, if you move from a point here to a point here, you are increasing your energy purchase, you are reducing the purchase of capital. So that sort of adjusts your cost so that you can stay on the same line. This is the concept of ISO cost. And the slope of the ISO cost line is given by minus PE by PK. And the absolute slope is again the relative price, which is PE by PK. The next concept that we are going to discuss is the isoquant lines. So isoquant means equal quantity is being produced. So if you think about a line like this, I have written Q0 equal to 2 ton. So this particular curve represents a production of 2 ton of steel, for example, right? And this particular producer has to produce 2 tons of steel given the capacity that it has. So the target is set as 2 ton of steel. This is called the isoquant line. Why is it isoquant line? On any point on the particular curve, the quantity of output produced is going to stay at 2 ton. It's not going to change at all. Why is it happening? See, similar what was happening in case of consumer. The consumer was reducing the consumption of one commodity and increasing the consumption of the other commodity in order to stay on the same indifference curve. Here what the producer is doing, the producer is actually using more of one commodity, one input, and reducing the use of the other input in order to produce the same. Now, what is exactly the shape of this isoquant line? That depends on the technology that you have in place. That actually you need to take care of the technological specification. But usually this is downward falling and convex to the origin for the same reasons that we have discussed in case of the consumers. So this is the equation for the isoquant line that is given. This is Q, that is the quantity of output that is being produced with two inputs, capital and energy. So as your input goes up, as you increase K and E, of course your Q is going to go up. So these are the positive. So Q is a positive function of K and E. Now if you move beyond the origin, if you go from Q0 to Q1, it's quite evident that you are using more of inputs, more of both the inputs or at least more of one input, and therefore your output is increasing. if you can further increase your, so there is a mistake here, this should be Q2 which is equal to 4 ton and not Q1. So you are moving from Q0 to Q1 to Q2 and your production gradually increases. So now let us have a quick look at what the slope of an isoquant tells you. So again, you can recall what was the concept of MRS, the marginal rate of substitution. Here in the context of the producer behavior, this is called the marginal rate of technical substitution. And this actually refers to, for this particular diagram, it refers to the amount of capital, that is the amount of one input that you need to add in the production process to maintain the same level of output if you reduce the energy demand. So what is the rate at which capital can be substituted by energy, or the rate at which energy can be substituted by capital? Now it may seem a little bit abstract, but the relationship between capital and energy is very, very important. Because you think about a situation, there is a lot of discussion about energy efficiency in the industrial sector. Now if you want to install energy efficient technology, that is going to increase your capital cost. So your capital is going to go up. However, once you install the capital intensive technologies, you can expect that your energy consumption is going to go down. So basically, you are staying on the same isoquant and you are gradually moving to this direction. If you are replacing your less energy efficient technology with more energy efficient technology. Now, how much capital do you actually need there in order to substitute some part of energy? That again depends on technology, and that depends on whether that's sort of an economic decision. It has any, it gives you any kind of saving or not. So this is the interpretation of the slope of the isoquant curves. And as I said, if you move along this line, you are using both the inputs at a greater quantity, and therefore you are actually producing more of output. Now one point of caution that you have to understand, when we are talking about the movement along this line, we are saying that both capital and energy can be varied. Now this happens only in a longer term. In the short run, we assume that capital is fixed. So in the short run, the movements are usually along the horizontal lines. But here in our discussion, we will consider the long run movements where we assume that both capital and energy can be changed. So this is the basic framework of, this is the basic framework for the producer. So what the producer wants to do now? For the producer, some amount of production is fixed and the producer is trying to choose the minimum isocost line based on which it can go on for that production. So the producer equilibrium problem looks like this. The objective is to minimize the cost, which is C equal to PE multiplied by E plus PK multiplied by K. That is the expenditure on energy plus the expenditure on capital. Subject to, for example, Q equal to Q1, which is 3 ton. So this particular farm, it has to produce 3 ton of steel. Now these are the different isocost lines that are available to the farm. Which is the lowest isocost line that the farm can choose? Obviously this is this line, because the same amount of production can be made at this point. So if the production takes place at this point, here also 3 tons of steels are being produced, but the cost is much higher. So the producer, what will do? The producer will actually come back to a point E0, which is the equilibrium. And at equilibrium, you see, this is the amount of capital and energy that is being consumed by the producer in order to produce 3 ton of steel. So at equilibrium, as we had seen in case of consumer, here you see that the slope of the isoquant is actually the slope of the isocost line, or you can say that the marginal rate of technical substitution is actually the relative price of the inputs. So here is the producer's equilibrium, and for the production, this is the energy input demand for the producer. So this is how the energy demand, this is the energy demand for the producer. And if you add one more panel here, the way we did it for the consumers, you can actually vary the price of the energy and you can get the energy demand curve for the producer in the similar manner. In a nutshell, this is the framework within which the producer's demand for energy and consumers' demand for energy is discussed in economics. and we'll just explore one example to understand how the problems are solved so that it becomes more clearer to you. So we start with this example. Suppose you have 2000 rupees as a consumer, you have 2000 rupees and you want to spend the money on petrol and pizza. So you have to divide your 20,000 2000 rupees on petrol and pizza. Now 1 liter of petrol costs 70 rupees while one pizza, so you can think of a small pizza that costs you 50 rupees. Now the question is how you are going to divide this money between pizza and petrol. Now suppose your utility function, this one, it captures your preference pattern and the utility function is given by Q1 to the power 0.6 and Q2 to the power 0.4. So remember Q1 is the petrol and Q2 is the pizza. The question is where will be your equilibrium? And the second question is how does the demand curve for petrol look like? So let us have a look how we are going to solve this problem. So the objective that we have is to maximize the utility which is given by this function. So this is basically represents your indifference curve. Subject to the budget line 70 Q1 plus 50 Q2. Now why 70 Q1 50 Q2? Because here you see we have said the price of petrol is 70 rupees and price of pizza is 50 rupees. So 70 Q1 plus 50 Q2 should add up to 2000. So this is your budget line. So this is the constraint that you have. As I have said, you can always formulate a Lagrange and solve the problem of constraint optimization. But you have some liberty in case of a two commodity framework. As you can see here that the slope of the indifference curve is equal to the slope of the budget line. So we have first derived the slope of the indifference curve. So this is the absolute slope of the indifference curve which is presented by MRS, and that is 3 by 2 Q2 by Q1. So this is the marginal rate of substitution. This is the rate at which the consumer will substitute one commodity by the other in order to be able to stay on the same indifference curve. What is the price ratio? The price ratio is 7 by 5. So 70 is the price of the first commodity, 50 is the price of the second commodity. So at equilibrium, that is at point E, what do you have? You have MRS equal to P1 by P2, and that gives you a solution Q2 is equal to 14 by 15 Q1. Now what do you have? You have two linear equations in Q1 and Q2. So one is Q2 equal to 14 by 15 Q1 and the other is your budget line which is given by 70 Q1 plus 50 Q2 equal to 2000. So from these two equations easily you can solve the values for Q1 and Q2, and what you see the optimum amount of Q1 that you are going to buy at point E is 17.1 liter of petrol, and here if you plug this value 17.14 here, you get the optimum amount of Q2 which is 16. So finally, given your preference pattern and given the money income that you have, you are going to buy 17.14 liter of petrol. This is your demand for energy, and 16 pizza. So this is how your equilibrium look like. Now coming to the spending. There are some other corollary which are very important and interesting. What is the total spending on pizza and what is the total spending on petrol? See, your total spending is P1 multiplied by Q1. So for petrol, your spending will be 70 multiplied by 17.4, that is 1200 rupees. Now if you observe, in aggregate you had 2000 rupees. Out of that, 1200 is being spent on petrol. So this is the 60% of your budget. So 1200 out of 2000, that is 60% of your budget. On the other hand, if you see how much you are spending on pizza, this is actually 800 rupees, 50 multiplied by 16. So 40% of your budget is going to pizza, whereas 60% of your budget is going to petrol. So from this pattern, what you can actually see, you are spending, your expenditure share towards energy is higher than your expenditure share on the recreational activities here. The other important thing to observe, what is the shape of the demand curve? See, we said that the correspondence between P and Q, that gives you the demand curve. So what is the demand curve for petrol? That is P1 Q1 equal to 1200. So P1 Q1 1200 means if you draw this on P1 Q1 space, this is going to give you the shape of a rectangular hyperbola. So this is not a straight line, this is actually a downward falling rectangular hyperbola which is presenting your demand for energy. Similarly, if you look at this P2Q2 which is equal to 800, this gives you the demand curve for pizza. And for the similar logic, in the P2Q2 space, this again is your demand curve which has the shape of a rectangular hyperbola. The final thing that is most important to observe, this particular form of utility function, this is called the Cobb-Douglas function. This is used for the utility function. This is also used to represent the production function. So this Cobb-Douglas utility function is very interesting because if you simply by looking at it, if you look at it, you see it's Q1 to the power 0.6. And what was your spending on petrol? That was 60%. So the power of Q1 actually tells you what is the proportion of expenditure being consumed on Q1. The power of Q2 tells you what is the proportion of your total expenditure that is going to Q2. So 60% money you are spending on Q1 and 40% money you are spending on Q2. So, you know, once you keep on doing this kind of an exercise, just by looking at the utility function and the total amount of money that you have, you should be able to infer what is the demand for Q1 and what is the demand for Q2 even without solving the whole problem. So this is the broader economic framework within which the consumer's demand and producer demand for input, that is energy input, is discussed. So we are going to stop here in this lecture. In the next session, we are going to come with some of the analytical frameworks that you use in order to understand or in order to measure the demand for energy. Thank you.